Okay, just got done talking about geometric series, and geometric sequences are pretty closely related. There's infinite, there's finite, and what it makes it geometric is that there's a common number that you're multiplying to get from the first term to the second term, from the second to the third, and so on. The only difference between a series is we're going to take the commas out and we're going to put a plus in between, and we're going to find the sum of, say, the first four or the infinite number of series. So again, you got finite, it stops, so there's only four terms here, added up. Infinite, you got four terms, but dot, dot, dot just kind of means that it goes on forever. Now, if it is the sum that you're looking for, and what I mean by sum is taking all those numbers and adding them up, of a finite geometric sequence, you have this formula that's worked out really nice for you. S instead of A, so S just means the sum of n number of terms. So if I, for example, in part A, want to find the sum of the first 10 terms, it would look like S with a 10, okay, is equal to the first term. So the first term is 2. Okay, remember this R is what's the number that I constantly multiply to go from 2 to 8? 4. I'll multiply by 4. I'll multiply by 4. So I've got 1 minus 4 raised to the 10th power. And the reason why it's 10 is because we're looking for the sum of the first 10 terms. On the bottom, I've got 1 minus 4. Again, you'll be using a calculator on this. Don't think you'll need to do this by hand. I'm just going to do what I think your order of operation should be. The bottom part is going to become 1 minus 4 to be 3. The top part isn't. So be very, very careful. You're actually going to want to take 4 to the 10th and then go 1 minus whatever that number is. So 4 raised to the 10th power is 1048576. So I'm going to go 1 minus that number. And that's going to give me a negative 10048575. Now, I missed something here. That should be actually negative 3. I'll divide it by negative 3. And then don't forget to multiply by the outside of 2, the outside number, and get 6,000 or 699,050. So what that represents is if I were to write out the first, second, all the way to the 10th number and add those up, I will get 699,050. Okay, that's a finite geometric sequence. Now, I know it says dot, 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 but I'm making it finite because I'm cutting it off at the 10th spot and then adding up those first 10. Okay, so consider the geometric sequence of 1, 8, 64, and so on. Again, I need the first number. I need the common number that we're multiplying by over and over. And we're trying to find the first 8. So it's the sum of the first 8. The first number, 1 minus the common ratio of 8 raised to the 8th power over 1 minus 8. Okay. So on the top, I got 1 minus 8 to the 8th power. Okay, pretty big number, but I got negative 16777,215 divided by 1 minus 8, which is negative 7. Okay, and then I'll multiply that by 1, and I get 2396754. So that's looking like 2,396,754. Okay, again, that would be finding all the way to the 8th number, cutting it off, and adding those 8 numbers up. Pretty big number, but think, again, we're talking about growth with a growth factor of 8. So exponential growth of 8. Suppose you go to work for a company that pays you 1 cent on the first day. Oh, 1 cent. It pays you 2 cents on the second day. 4 cents, sorry, not comma, decimal. 4 cents on the third day, and so on. Each day your wage doubles. Well, yeah, it does, because the 1 cent to 2 cents, we're going to take times 2, take times 2. We're going to find what your total income would be after 10 days, 20 days, and 30 days. So the total income would be the sum of the first 10 days. Again, It's geometric because we're doubling these. So there's your initial 1 cent. 1 minus, sorry, not 1 cent there. That should be the 2 because we're multiplying by 2. Raised to the 10th power over 1 minus 2. So this is the old, would you rather take $1 million or would you rather take a penny, but it doubles after 30 days kind of problem. I don't know if you've ever heard that thing. And because of the exponential growth, it's actually better for you to take and grab the penny. And that ends up being $10.23 when I calculated that out. Now the sum of 20, let's double check, and I'll let you do 30 here, but I want to just ask you, do you think it just is that 10-day number doubled? Well, let's find out. So 1 minus 2 raised to the 20th power divided by -1 and then times the 0.01. Don't forget about multiplying by the A1, the very first term, and I get $10,485.75. So after 20 days, this has grown quite a bit. In fact, if you were to figure out 30 and all that would change is this turns into a 30, I bet you get quite a bit of money as well. Okay, so that would be a finite geometric sequence. There's your formula for that. There is such a thing for the infinite ones, and I can show you that if you're really curious. We're not really going to spend a whole lot of time on it, or if at any at all, but that's finite geometric series when you're adding them all up.